Okay, so this is the homework for the Unit 2 Chain Rule Day. I had a request for some problems from this to be worked out. So when you're using the chain rule, remember, you would use it in an example like this. If you're trying to take the derivative of a function within another function, that is a clue that you want to use chain rule. So here when you use chain rule, you would say that the derivative of x, we're going to take that 6, multiply it by this 1 in front. So it's going to be 6. You recopy what's in the parentheses, and you decrease the exponent by 1, so that becomes the 5th. But then the chain rule says that you have to then take the derivative of what's inside the parentheses there. So the derivative of what's inside there is just a -7. And again, if it was a free response, you'd be more than welcome to leave your answer like this. Or if you wanted, you could rewrite it as -42 times the quantity 8 minus 7x raised to the 5th is your final answer. Okay. For the next one, I would interpret this square root as the whole thing raised to the 1/2 power. So I'm just going to rewrite it as 2x to the 4th plus 1 quantity to the 1/2. Whenever you see square roots, you want to go ahead and rewrite it to the 1/2 power. And now I would apply the chain rule. So again, I note that I'm taking the derivative now with that k prime. So when I take the derivative, it's going to be 1/2. You just recopy the part in parentheses as is. You decrease the exponent by 1, so 1/2 minus 1 is going to be a -1/2, multiplied by the derivative of the inside. So the derivative of that, 4 times 2 is 8x cubed. Okay, and again, you could probably rewrite that if you wanted. Let's see, this is going to be in the denominator, the 2 will be in the denominator, and then this whole thing will be in the denominator because of that negative exponent, and I'm going to take the square root of it. So the only thing left in the numerator, I could use this 2 and take out that to rewrite it as a 4. So I would say the final answer could be something like 4x cubed over, I already got rid of that 2, so then in the denominator it's going to be the square root of 2x to the 4th plus 1. For C, one of the properties of derivatives says that you are allowed to take derivatives term by term. So I'm going to tackle this first term here, and that's going to be using our very simple power rule. So the power rule says if you're trying to take the derivative, and it's fine that it's a theta, you could change it to an x if you prefer. You're just going to go ahead and say that that's going to be 3 theta squared. Okay. Then you're going to have to take the derivative of that second part. Well, remember, this second part, think of that as cosine theta quantity squared. So that's actually going to be a chain rule. Okay. So it's going to be plus 2 cos theta. Okay. Then the derivative of the inside, right? Because the derivative of that cosine of theta, the derivative of cos is negative sine. And those are multiplied together. So we've got that, and again, that may be rewritten as 3 theta squared minus 2 cos theta sine theta as your final answer there. So the next one is asking you, given some variables here, so notice that this is a polynomial. There's no product rule or anything that needs to happen here. It's just using your straight power rule. So you would say 2 times a to find the derivative. So the derivative there is going to be 2 times a, and then the x will be just to the first power now, plus it would just be b, the x will be gone, and then when you take the derivative of a constant, then you aren't left with anything there, so that part's finished. Alright, going on to e. Remember, whenever you take the derivative of e to something, well, you just recopy it, and then you take the derivative of the exponent and write it out front. So here, the derivative, so g prime, I recopy it, and that's to the -0.5t, but then I multiply that by the derivative of that exponent. Okay, so the derivative of this exponent is just -0.5t, so -0.5t. And those are all attached by multiplication there, so negative 0.5 times 1,000 leaves you with just a 500. Oh, but it's negative, so negative 500 e raised to the negative 0.5 t. Next, when you're trying to take the ln of something, the derivative of that is going to be 1 over the something times the derivative of whatever is in the denominator there. So here the derivative is going to be, so the derivative of ln of cos is going to be 1 over cosine of x multiplied by the derivative of cos. Well, the derivative of cos is negative sine, and that's attached by multiplication. You can rewrite that as negative sine x over cos x if you prefer. And then if you kind of write it like that, if you think of this as, or did I say that right? Is negative sine x over cos x. And if you remember from pre-calculus, you can then rewrite that as negative tan x. So if that was a multiple choice, just be careful. They may have reduced it, and that is still negative though, so just be careful there. And finally, we're moving right along to G. So in G, okay, be careful. I would rewrite the original here because this squared is on the tan, but it's not on that 5, okay? So this is the same thing as if it was 5 and then tan of 5x, that part, squared, okay? And I think when you write it like that, it makes it a little bit easier to see that you want to use the chain rule. So when I take the derivative, this is going to be h prime. So when you take the derivative of that, it's going to be 2 times 5. It's going to give you 10. You recopy what's inside, and you decrease the variable, but that'll just be a 1. So it's going to be 10. And then that's tan of 5x. Okay, but then remember, we need to take the derivative of that. Well, how do you take the derivative of tan to the 5th? Well, very similar to our notes from day 1, that's going to be another chain rule inside of there. So the derivative of tan is secant squared. So it's going to be secant squared of that thing. But now I have to take the derivative of that because I still have that parentheses. So the derivative of that is going to be a 5. Okay. You can then multiply this 5 with this 10 if you wanted to kind of clean it up just a little bit and rewrite it as 50. Tan 5x secant squared 5x. And I would leave my final answer like that. Okay. Last one for this number 1. I would rewrite the original again. Whenever I see a square root, I should be thinking raising that to the 1/2 power. This square root is in the denominator. So when I rewrite it with that in the numerator, it's going to become x squared plus 1 raised to the negative 1/2. Okay. And now I can use chain rule again. So again, now I'm taking the derivative, so I can use that notation of y prime. Negative 1/2 times 1 is going to leave me with a negative. You can write a negative 1 if it makes you feel better. And I recopy what's in the parentheses. This time it's an x squared plus 1. I decrease the power by 1. So if my power was negative 1/2 and I subtract 1, that's going to be a negative 3/2. Okay. And then I need to multiply that by the derivative of what's inside these parentheses here. So the derivative of x squared is just a 2x. And you probably would bring that out front, so it would be negative 2x times this, negative 3/2. And again, if you wanted to rewrite it again with this in the denominator, so it would be negative 2x over the square root of x squared plus 1 power over root. So that would be to the 3rd power there. Okay. And that's all number 1. So I'm just going to scooch this up so I could tackle number 2. All right. In number 2 here, it says, basically I'm just asked to find the first derivative. Then I'm asked to write the equation of the tangent line at 0, and then find the second derivative. So these are all talking about that first problem. So this is going to be a chain rule here. Okay, so when you're finding the derivative, we are just going to rewrite that times the derivative. So, okay, the derivative of sine is cos. So the derivative of this, you're going to say it's 4 cosine of what's in the parentheses there, right? Multiplied by the derivative of that. Well, the derivative of what's inside here is a 10x. So there's that. Again, if you wanted to rewrite that as 40x cosine 5x squared, that's fine. And now we're going to write the equation of the tangent line at x equals 0. So we have a derivative from part A, and now we're just going to evaluate that derivative at 0. So I'm just going to say dy dx evaluated at x equals 0. That's just showing that I'm plugging 0 into the derivative. So if I plug 0 into the derivative there, well, that's interesting. That's going to give me just a 0, right? Because if I plug in 0, that'll be 0. Cosine of 0 is 1, but 0 times 1, right, is going to be 0. So you can even write that if you wanted. Okay, so I have a 0. And I'm writing the equation of a tangent line. So this is the slope at that point, okay? But if it asks you to write the equation of a line, right, you should be thinking y minus y1 equals m, parentheses x minus x1. Not that it's going to matter much here because this is going to be 0 times whatever. You don't care. It's going to be a big old 0. And if I plug in 0 into the original, okay, sine of 0 is 0, so it's going to be more zeros. So it's going to be this minus 0, this minus 0 there. So basically you just get y equals 0. And you're done there. Don't let the zeros fool you. It's perfectly fine to have 0 as an answer. And let me just scooch this up a little more so you can see. Okay, and then the last one on this page, it's just asking you to take the derivative of something you already took a derivative of. Okay, so now I'm working with this part from A, and then you have to take the derivative of that. So when you're taking the derivative of that, what I would do is kind of think of this part here as part 1, and then this part as your part 2. So I'll just kind of label that part 1 and 2. And you're going to have to use your product rule here. Okay, so remember, product rule says first times the derivative of the second plus the second times the derivative of the first. So that's what we're going to use to come up with, let's see, so we're going to have first times the derivative of the second. Now the derivative of the second, within there is a chain rule, okay? So this is a little tricky. So if I asked just for the derivative of this, well, derivative of cos is negative sine, so it's negative sine of that thing, okay, times the derivative of the inside there. So that's times 10x. Okay, so remember, we're still in this big product rule, though. So we have first times the derivative of the second plus the second times the derivative of the first. Well, the derivative of the first is a lot easier. So that's going to be a 40, and you've got that. Okay, and, oh, that's all we had to do. So you can clean it up if you want, or you can leave it like that. And that is the front of your homework, okay? Okay, you can stay tuned for part 2. Okay, and I want to